Awesome. Thanks, everybody, for joining me today. This is my first time talking at GraphQL Chicago. First time, as a matter of fact, talking at any GraphQL-specific meetup or conference, and mostly in the security space, so oftentimes talking security conferences and so on. So very excited to be here. To introduce myself to you, my name is Dolev, Head of Security Research at Inigo. We're a security solution for your GraphQL API. We give you the observability layer and security layer, no matter what GraphQL implementation you use. We recently opened up our platform for users, so you can just try it out without even talking to anybody. I personally learned about GraphQL back in 2020, so not too long ago. And I basically worked at a fintech company. They had GraphQL everywhere, deprecated REST for GraphQL. And I was like, what is this all about? I got to learn as much as I can about it. Coming from a security background, I needed to know what GraphQL is to be a better security engineer for the company and protect our own APIs. Fast forward 2 years later, all these learnings and experiences and fails and things that really worked well made me go and write a book. This book was written by myself and my friend Nick Alex. We co-authored this book called Black Hat GraphQL. By No Starch Press. It's available today in early access version. At the bottom of the slide, you can find a 25% discount code. Basically, this book is a pen testing book that is, the audience for this book is both security professionals as well as developers who are looking to do things like test their own APIs to make sure that they're resilient to some of the types of attacks that are tailored to GraphQL. So with that, I want to move to the agenda for today. The agenda is, on the surface, very lightweight, but there's a lot of things that are involved in here. So we're going to start with the GraphQL security overview. I'll talk about some of the things, like some of the challenges and the mitigations for these challenges. You may hear some opinions, some hot takes, some things that I just ran into over time and kind of learned. And then we'll kind of pivot to doing analysis on publicly disclosed vulnerabilities related to GraphQL components. And we'll finish off things with a live attack demo against a GraphQL endpoint, so you can kind of see how things look like on both ends of an attacker as well as a server. So I learned that when I picked up GraphQL a while back, I learned that there are certain security challenges that are GraphQL unique or unique to GraphQL, and certain things that are not unique to GraphQL. For example, if you're familiar with the OWASP top 10 like API top vulnerabilities, you will see things like injections or forgery-based vulnerabilities or hijacking-based vulnerabilities. These are things that are not really unique to GraphQL. They can exist in any API. But I learned that GraphQL introduced certain things that can make certain attacks more efficient. And the same vulnerabilities apply in GraphQL. For example, the two dominant categories that I'm personally seeing a lot fall under two main buckets, which is denial of service, or like resource exhaustion, and authorization. And you will see that, for example, in the denial of service part, there are certain things that are unique about GraphQL that makes it easier to exhaust a GraphQL server. So when you send up a GraphQL server or an API or an application backed by a GraphQL API, addressing some of these vulnerabilities will require some additional tooling, whether it is like external libraries to fix certain behaviors or make certain configurations more hardened, or you may end up building in-house tools to address like observability issues, or if you want to mitigate against certain queries, you may have to build certain tooling internally to first be aware that they're happening to possibly block them. Or you can go to the commercial side of things where you have platforms that basically give you security and observability as well. And the security industry is slowly catching up. You will find new tooling, new testing tooling, new resources that are being made available, blog posts, both commercial and open source tools that are being created to solve some of the GraphQL security and observability challenges, specifically from a security perspective. So I want to kick things off with authorization. So I had a conversation with a friend of mine who I very much respect, and he's doing a lot of things in the GraphQL space, and we talked authorization. And he had an interesting take where he thinks that GraphQL is not responsible for things like security and authorization, which is an interesting take. I also heard other opinions that are different. So whether you want to, if you want to implement authorization, you have multiple choices. You can tightly couple the authorization with GraphQL, or you can even decouple it from GraphQL. At the end of the day, it's a decision that you need to make for yourself. I don't think there is a right or wrong. There's different approaches, each with its own pros and cons. But if you start like Googling how to do authorization, you might end up with more questions than answers, just because there is more than one way to do something. So for example, some implementation types of authorization and also authentication is, for example, enforcing authorization at a gateway level, or maybe annotating your schema with specific custom schema directives that allow you to say, okay, these types of people or these types of roles should not be accessing these parts of the schema. You can also implement authorization within the resolvers themselves, or you can completely decouple that, so you separate your authorization layer completely from your GraphQL, essentially outsourcing or offloading those decisions, the decision making, to an external system. Schema level authorization kind of looks like this. You could create your own custom directives that can indicate whether something or a certain query or a certain mutation require authentication as well as authorization. And you can assign certain roles so that only the clients that have these roles can actually execute these queries. So this is one way of doing this. Some cons to this is if your schema gets really, really big, then you want to make sure that anything that gets added to your schema as it evolves is the right directives are in place. And if things are deprecated, or if you suddenly change roles and capabilities, you need to make sure that those directives still make sense where they're configured. So it's just something that you have to keep up with and ensure that any new changes that somebody makes has all the necessary security controls, and you don't have like you don't end up with like a deployment in production and suddenly you have a query that's like unauthorized or unauthenticated by default. Another approach, which is something that we also do at Inigo, is like a query path-based and a type-based like authorization. On the left, you have like this superset type of query that you define, and any client that makes use of any of these fields will be able to do that. And then you can couple that with type-based authorization, where you say, so for example, if you have a people field in the query and people field is of type person, you can surface very specific fields from that type to specific clients. So for example, if a type person in the schema has 4 different fields, you can basically surface only a subset of those to certain clients depending on their roles and permissions. So this combination of 2 things allows you like granular access to certain things. Another approach is to completely decouple your authorization, like with a sidecar pattern. You could have a service that does both the decision-making and the enforcement, or you have an authorization sidecar that simply is responsible for decisions, and the enforcement of those decisions happens at the service layer or the GraphQL layer. One common example is if you've ever heard of Open Policy Agent, is basically a way to create like policy as code kind of approach to authorization. You have a service that is responsible for the authorization, but it's not what's enforcing it. It's just something that returns a decision to your client, in this case, your GraphQL API, and the logic, who can access what, lives within that sidecar, within that authorization service. A couple of rules around like authorization that I personally find really useful. So no matter what solution you choose for security, for security people, there's going to be a couple of things that are important. Whatever solution you choose, make sure that like auditing the access, the changes that happen to access, the policies changes, is accessible to both developers and security people. Typically, authorization layer is not something that changes that frequently, but at the same time, it's not static. So it also depends on how complex your API is. But if you do have a lot of changes in your authorization layer, new services and things like that, make it easy for people to audit what is the current state of affairs in your authorization ecosystem. You may have roles that overlap. For example, you may have an admin role that does one thing in one service, but does another thing in another service. So having the ability to know what each role does in each part of your ecosystem is very helpful, not just for security and devs, but also for auditors if you go through an audit. Your authorization layer should be logging both positive and negative cases. The reason why this is important is because if you make some kind of a mistake in your authorization layer and you suddenly end up with clients being able to access data that otherwise you shouldn't have access to, then those are positive cases. Those are successful attempts that clients made that could result in a security incident. So you also want to make sure that you capture those so that you do know if you had a hiccup in your authorization layer, who had access to what. Same thing on the inverse, same thing on the rejects. So if you make a change and suddenly clients are getting rejected and they're not able to fetch certain data, that's also important to know. Because it also can indicate, for example, if some client is trying to access data they shouldn't have access to and they keep getting rejected, that's an indication for the security team to start investigating. Maybe somebody's trying to snoop around, figure out how to access data that they don't have access to, or something of interest that they really want to get their hands on. Number 3 is authorization by default. I feel like I don't think that there is like a lot of cases where you don't want authorization. You may have cases where you don't need authorization. Make authorization by default. And if somebody needs to implement like some sort of a query that returns something that is very innocent and it doesn't require authorization, make it based on like opt-out basis. So if somebody needs to introduce something new, they need to go through an extra step in order to opt out of that process. This way, the right teams can get engaged and figure out, is this the right thing for us? Is this the right thing for the company? Or can we actually introduce authorization for the innocent cases as well, just in case? And lastly, testable. So authorization from the security testing perspective is one of those things that are a little bit more challenging because you have different roles and permissions, and those are typically business logic and what the business needs. So if you have more than one role with certain sets of permissions, you want to be able to test your API from more than one perspective. So have a table of roles and permissions that gives your testing cases guidance in terms of what to test and how, so that you can figure out whether you have gaps between like different roles, which is really good for security testing and ensuring that any changes you make to your authorization layer doesn't result in suddenly access to restricted data is allowed by clients that shouldn't have access to that. So with that, I want to pivot to denial of service. This area is very interesting for me personally. I'm not sure why, but it is. So GraphQL gives some power to the client to ask certain things from the API, either in a very simple or very complex way. That's one of the power and the great benefits of GraphQL. So you might have clients that make very simple queries, but you may have clients that make very complex queries. Typically, we don't really know, should we trust our clients? Should we not trust our clients? Because you may end up with, you have a SaaS platform, people register, you don't know what their intentions are. So typically, from a security perspective, you don't trust the client ever. So you do want to be ready to handle things that you did not expect. And when you stand up a GraphQL application, there are certain additional steps that you need to make in order to make sure that you still have some power and control over your destiny. So if you do have a client that is asking for a lot of information, make sure that your GraphQL server can handle that. So today, basically, from what I've seen from different implementations, some offer you more features than others. Also depends on the maturity level of the implementation and the number of developers in that ecosystem. So naturally, you're going to have more mature players and immature players, or even newer players. So they may offer things that the other doesn't. And lastly, the last bullet is not many security controls or traditional security controls that are not really related to GraphQL, things that you would typically see in like a company setup, like web application firewall. Not many of them necessarily understand GraphQL semantics. Web application firewalls have been mostly placed in front of like REST APIs, and I'll touch more on like the differences from a security standpoint. But security controls are protecting your GraphQL API should be able to know what is a complex query, what is a query that looks like it's suspicious, and what is a query that is something that maybe we want to actually process. Over the years, I've learned that there's more than one way to take a GraphQL server down, or at least exhaust its resources to a point where the service is degrading. And I put them under 3 buckets. The first bucket is application level denial of service. What I mean by that is maybe you created like a query, and this query gets some kind of records from the database. And on its own, this query doesn't take any arguments. But But there's an optional argument, for example, where you specify a limit, and the client can specify the number of objects they want to return. If you don't check the upper boundary of those limits, then the client can ask for a lot of data, let's say 100,000 records or 10,000 records. Maybe a few of these requests will not do anything, but if somebody is bombarding your API with this, then it may impact your servers, and you will see some kind of performance degradation. The second bucket is abuse of the GraphQL query language itself. Certain things that exist in the GraphQL query language that allows you to carry certain attacks in a way more optimized way. And number three is like GraphQL Server implementation specific flaws or absence of certain controls in certain implementations that allows you to attack that particular GraphQL server in more ways than, for example, a more mature GraphQL server. And I'll touch on some examples immediately. The first thing that I want to touch on is aliases. Aliases is interesting because it allows you to run more of the same query more than once. You will basically get 3 responses to the screenshot above to the same query. Aliases can be used to basically execute complex queries more than once, but they're not only useful for denial of service, they're also useful for defeating authentication and validation mechanisms. So for example, if you have a login query, and you can stuff a bunch of login queries in using aliases in a single query and try to brute force accounts this way. The reason why this is interesting in the first place is I want to go back to the web application firewall part. So web application firewalls that protect REST APIs and login endpoints, you would typically see rate limiting rules that security engineers would set that would say, if a client is making a post request to v1 login more than 5 times in an hour, ban them for 24 hours if the response code is 401 or something like that. You have specific HTTP indicators that may signal something weird is going on. Maybe somebody's trying to brute force accounts. Maybe they're doing like credential stuffing. So this is how web application firewalls are also operating. You can rate limit this way based on, if you see a volume of those requests coming in, that's enough evidence that you should probably block a client who's trying to do that. But with aliases, you can actually do a similar thing and stuff a bunch of aliases that perform a login attempt, have 100 of those, and just send a single HTTP request. So what a web application firewall would see and what a security engineer would see is just a single, possibly post request to a single endpoint like /GraphQL, and they will not have any more data about whether this is malicious, what should I do with this, what does it mean? And this is like the reason why I'm saying that web application firewalls should be GraphQL aware. So at least they give you the control over or the visibility into what's going on, so you can block accordingly. So aliases is an interesting way to defeat token validations, mechanisms, logins, and things like that. The second part to this is you can also batch queries using arrays. And please correct me on the call if I'm wrong on this, I've never seen any evidence for this feature like the spec, but this is something that certain GraphQL servers allow. So you can essentially create an array of queries, put them in an array and send them to the server. It will process them one after another and return a response of all these queries together. The difference between arrays and aliases is that with arrays, you can mix queries and mutations together, where in aliases, you can only use either only queries or only mutations. So if you do have some kind of a API flow that you want to follow and send a bunch of like queries and mutations followed by like queries and mutations and queries and mutations, arrays enable that or allow you to do that because they can mix different types. So this is another interesting thing that I ran into. Certain GraphQL servers allow you to do that without the ability to disable that. And some do allow you to disable that. As an example, Graphene in Python, I think, allows you to disable batch queries using arrays. Another example, this is probably the most popular one, which is circular queries. If you have a bidirectional relationship between different types in your schema and they get exposed through some query, then somebody can construct a recursive query. This is probably one of the more well-known ones. So the popular implementations will typically have some kind of a document dedicated to this problem. And you may have like a certain value or a certain configuration that you can set to define that maximum depth limit that you accept. So this is one of the things that you should expect to see in the GraphQL server that you're adopting. similar to circular queries, there's one thing that I found personally interesting when I was reading the spec, which is circular fragments. So in the spec, there is a section 5522 that talks about fragments that they should not form cycles. So you can actually create two fragments that reference one another. So in this example, we have fragment A and fragment B. In fragment A, we specify a bunch of fields from the schema type. And at the same time, we also call fragment B. And in fragment B, we call back fragment A, or we include fragment A. So when we make a query to fragment A, we end up with A calling B, B calling A, and then you end up in this never-ending loop. So since there is a section for this in the specification, most popular implementations have those validations already in place. I personally have seen a GraphQL server that's more niche, less mature, that didn't have those in place. And this single query and a single request will completely take it down. But this is an interesting area to explore. So I invite you to check internally in your dev environment if you're a GraphQL server, whether you built it yourself or you use one of the more common implementations, that they can actually reject those. Field duplication is probably the most naive way of trying to exhaust resources. It's probably also the least useful, or it requires more resources from an attacker to actually do that. If you take a bunch of fields and you duplicate them n number of times, the response that you will return to you is a single owner field in this case. But if you do timing analysis on the response, you will see that it's gradually taking more and more time. This is on its own is less effective to bring down a server. But if you combine and chain this type of vulnerability with another thing, which is sending a batch of queries in a single request, it becomes a little bit more complex, and it becomes a little bit more effective. But this is one way of also exhausting the GraphQL API, simply because something on the backend is going to process that. And although you'll see a single response, it's still taking its time to process each and every field. A couple of rules around denial of service. So there are libraries that can help you protect your API from, using kind of methods like static analysis and cost assignment and things like that. The problem with those is that they're typically stateless, meaning that they check per query and they have no idea what the previous query was unless you save that state somewhere. So, and nothing stops an attacker from figuring out what's your maximum threshold and just send a query that is one field less, so that they fly under the radar, and they can execute many of those queries and not get rejected. So stateful is a better way to kind of enforce a client to behave when they send a lot of queries at the same time. Strict linting also helps. So if you see a query that is constructed really weirdly, duplicated fields or many aliases, things that you would not expect, for example, your front end or people that integrate with your API to do, then you can basically look at the structure of the query and just decide not to accept it. Or potentially you can normalize it and just flatten it and just execute what's relevant. And like I mentioned, web application firewalls don't really understand GraphQL semantics unless they're tailored to GraphQL. There are some of those. So use solutions that actually do so you can protect yourself better. And any queries that you see in your APIs that are being made by clients that look suspicious, log them securely so that your security team can take a look at them. It's always good to know how clients interact with your application and what they're trying to do. I want to move to publicly disclosed vulnerabilities and what they tell us a little bit about the state of things in GraphQL. So there's the MITRE CVE database. CVEs are typically vulnerability identifiers that certain software bugs get assigned. Not all vulnerabilities get a CVE. If you want a CVE for certain software bugs with a security impact, you would typically engage MITRE, and they will assign CVEs for you. And if you're a big enough of a player, you might be assigning CVEs for yourself. It's called CVE Numbering Authority, CNA. So if you look up GraphQL in the MITRE CVE database, you'll end up with about 45 different vulnerabilities since 2019. The first record or the first CVE on that list is from 2019. I personally don't think that this is the first ever vulnerability to exist in GraphQL, but at least based on the MITRE CVE database, this is the first vulnerability that has CVE assigned that has something to do with GraphQL. So keep in mind that not all vulnerabilities get a CVE, and in general, not all vulnerabilities are reported, so this is not a definite number. What's interesting, though, is the pie chart. So if you look at the breakdown of the vulnerability classes, more than half of the vulnerabilities on that list had some kind of an impact to on authorization. So either the component didn't have authorization layer at all, or it had an authorization layer with some flaws in it. Authorization bypass is followed by denial of service at almost 17%, and then you have smaller classes like injection and cross-site request forgery and things like that also exist, but less common. Another source for database of vulnerabilities is HackerOne. If you've never heard of HackerOne, it's like a bug bounty program management vendor. Companies basically list themselves on the HackerOne platform. They open up their APIs or their software for external people to come in and test their APIs. And they credit bug bounty participants based on what they find, based on the impact that it has on the company, and so on. So if you go on the HackerOne website and look up GraphQL, you'll end up with about 75, 74 vulnerabilities that go back to 2018, some of them at least. If you look at the pie chart, it's quite amazing that almost 90% of them are authorization related. But what's interesting and what I feel is kind of skewing the results here is the fact that bug bounty participants are motivated by money, and authorization has a larger impact when it comes to data security. So companies typically care more if they have authorization issues than if they have denial of service issues, which is why I think most testers put their focus on authorization so that they can maximize the bounty that they're going to get from the company and make more money, essentially. Denial of service in this case is only at 7%, followed by two other vulnerabilities that are vulnerability classes that are less than 3. The reason why I think the denial of service is so low is there's multiple reasons, but one of the primary ones is that most bug bounty programs actually ban or forbid you from testing denial of service-based vulnerabilities. They don't want random people on the internet, signing up to HackerOne and testing them and try to exhaust their APIs. They don't want any of that. Even if they're vulnerable to it, they don't want people to try and stress test their APIs. So this could be one reason why there's not many of them. The other reason is those programs that do accept denial of service vulnerabilities or denial of service testing will not necessarily credit the same way that they would credit for an authorization flaw, simply because they're typically not treated the same when it comes to impact on a given company. Denial of service is mostly impact on the availability of the app. Authorization is more on the confidentiality of the app. So those they're not given the same weight. So in short, no one is immune to vulnerabilities, but one of the first good steps is to be aware of what's possible, because GraphQL can be abused in different ways. And other thing that I highly recommend is to perform threat modeling. Threat modeling is a cheap exercise that you can do, and you can execute that with your peers or with your security team and uncover vulnerabilities in a very cost-effective way without even writing a single line of code, just by discussing your APIs. If you ask yourself, is what I'm currently developing or is what we already have in production vulnerable in some way? And if it's vulnerable, do we have the mitigations in place to protect that? And are the mitigations actually effective? These are the type of questions you can ask that would lead to very interesting discussions. And you will learn a lot about your APIs and how they can be abused just by having that simple conversation. So with that, I want to move to the attack demo. This is going to be a live demo. So if it doesn't work, I'm sorry. I do have a recording. So hopefully it works. But I want to explain a little bit about what's going to happen. So the scenario here is that we have a target server, and that target server runs WordPress. If you've never heard of WordPress, it's a blog platform, very, very popular. By default, when you install WordPress, I believe it comes with a REST API. But WordPress has an ecosystem and a marketplace for additional plugins that you can install to basically enhance your WordPress to be able to do other things. So there's one plugin specifically called WP GraphQL, which basically slaps a GraphQL API on top of your WordPress and makes it available for clients. Back in the day when I was looking at this about a year and a half ago, it was just a default installation of WordPress and that plugin. And there was nothing in between like the client and the server. There was no like security controls in place, nothing sophisticated, just a simple GraphQL API to a WordPress instance. Now to talk a little bit about the attack vector or like the exploit here, what we're going to be doing is we're basically going to run a script that constructs a query that fetches certain WordPress posts using specific fields like content and comments. And what we're going to do is we're going to create a query that consists of comments and content and repeat those fields 1,000 times. And what we're going to do, and we're going to take that query and add that to an array. And we're going to add 1,000 of those to an array. So we'll end up with an array of 1,000 queries. And each field within that query is duplicated 1,000 times, essentially. And then we're going to have a bunch of threads that sends that array every now and then. So what will end up happening is it's going to potentially overwhelm the API. So what I'm going to do now is I'm going to stop sharing my screen and share the entire desktop so you can actually see my terminal. So give me 1 sec. Bear with me. Okay, hopefully you see my screen. Okay, so we have a test WordPress. This is like a really normal plain vanilla WordPress with that plugin. And what we're going to do is we're going to just tail the log on the WordPress instance and see what happens when such attack is basically executed. So when you run this exploit, we're basically giving it 2 arguments of 1,000. So 1,000 for field duplications and 1,000 for elements in the array. And we're going to run that against the server. Hopefully this works. And we're going to wait a little bit and see what happens to the server. So what's going to happen is it's slowly going to start draining the resources until you will actually see out-of-memory errors. So the process of, I believe it's MySQL, is not able to recover. And therefore, the WordPress instance is not able to communicate with the database, which basically leads to the server hanging for as long as this query is essentially running. At some point, it's going to error out, and you will see like a SQL error. But this is how easy it is to kill a unprotected GraphQL API. There's a watchdog on the MySQL server, so it's going to start it up and eventually recover. But eventually, it's going to die like this, basically. So this is the example of how you would kill a API-backed application without any security protections in place. So I'm just going to share my screen and go back to the presentation. Can you see my screen?
We're seeing the folder.
Oh,
or
let me fix that. Now it's good?
yes.
Okay, cool. So why was this successful in the first place? So when you install this plugin, anonymous users are able to use that API. And this kind of makes sense because when you have a blog platform and you want to share stories about your cat or something like that, maybe you want the wider internet to read your blog posts. So in this context, anonymous access kind of makes sense. But that was the default kind of behavior back in the day. You could execute an array of queries against a GraphQL endpoint by default. There was no option to disable that. And the plugin itself didn't have any security controls in place. There wasn't anything that you could play around with or toggle that would make things a little bit better. But ever since then, this plugin improved a lot from a security perspective, and they fixed all of that. So that was a very interesting and successful engagement overall. So if you are interested in GraphQL security, I highly recommend looking at Damn Vulnerable GraphQL application. If you've never heard of it, it's like a flawed GraphQL application with a bunch of holes in them. But it's educational in the sense that you can see the challenges and the solutions to them and just play around with a really vulnerable application with a GraphQL API. So highly recommend giving it a try so you can kind of experiment with the type of issues that I covered in this presentation. And I think with that, that's all I had. Thank you. I'm really glad the demo worked, but I would like to open it up for people to ask any questions.
Did have a question in the chat.
Oh, let's see.
By Derek.
Derek, auth by default really depends on the API. Public e-commerce API, the vast majority of traffic will be coming as unauthenticated, forcing users to log in before letting them see search results would lead. Yeah, agree. Was there a question there, Derek? I totally agree with you. There are certain cases where you'll have users that should not be authenticated and you still need to serve them 100%.
It was just a general comment. So like saying
Yeah.
absolute to like start with authenticated, it's a very dependent on the API itself that you're building. So I agree in general, you should be always thinking about authenticating, authorizing users that they can do proper stuff. But there are cases then that you have to let the anonymous traffic in.
100% agree with you. And that's one of the challenges of security, like juggling the requirements of the business versus trying to actually protect the business as well. 100% agree.
All right, I think that's it for the chat. If anyone has any questions, feel free to unmute and ask them.
Yeah, so I guess I have one of my questions, I guess, at the moment is when it comes to some of the authorization and the different like examples that you showed. I know that's where I've kind of ran into some pain points with GraphQL, is just trying to decide, yeah, how to set up authorization, because it's still very much I don't know. There's not a strong consensus out there yet. So I don't know if you have any deeper experience that maybe you have some insights into, like, I guess I don't know if it's maybe the size of your user base, or if there's like some sort of conditions that you might use to try to make that decision on which approach you would actually go with.
Yeah, it's a good question, and I think that the answer will vary depending on what you're trying to do and how big your application is, how complex it is. The permission model, the authorization model that your application has also is going to influence how complex the solution might be. I personally saw multiple approaches. One of the more recent ones is the decoupled authorization, where you have an enforcement layer, an authorization layer that basically holds all your policies, the data about who can access what. And that's all it knows. It gets a payload from your API, it parses it, try to basically figure out based on the data and the policies that it has, whether it's allowed or denied, and it returns either a Boolean statement or some other type of data to the client, which in this case, your own service. And the service is the enforcement point where the service will need to make a decision to reject that query. So the rejection doesn't happen at the authorization layer. Completely decoupled. That allows you to have visibility into your access control, even if you have more than one service or more than one GraphQL API, which is kind of nice, this for the security, from a security perspective. And you have basically all your policies centrally managed by centrally managed, logically distributed, because those end up being like in sidecars and next to your different applications, but they all hold the same type of policies. So your policies are essentially centrally managed but logically distributed. That's one way that I saw how you can solve authorization for more complex scenarios. It's not always like a two-dimensional thing where this role can access this object. Sometimes there's more involved. So it really depends. That's why I think there's no like best solution. There's certain things that has pros and cons, depending on how complex you need the authorization to be.
Sure. Okay, that makes sense. Just kind of general, I guess. Just if there's just kind of a scale of complexity, both in regards to what your policies might, the granularity of your policies and users first, and also I guess the complexity of your system as a whole. Yeah, that makes sense.
Thank you for the question.
Cool.
Cool. I think looking at the chat, I don't think we have any other questions. Bill, anything on your end? You're on mute if you forgot.